Hello and most welcome to 1164 of the Heidegger series. We are currently in the county of Gråbo, maybe 20 miles, 35 kilometers from Gothenburg proper. We will continue with Henry Stapp, and what is needed to understand his standpoint is that we put what is behind all of quantum mechanics into perspective, and the neglect that is the quantum interpretation from Copenhagen, in contrast to the orthodox interpretation. The orthodox meaning we are not compromising, or we're just looking at what we can observe, not caring what is practical or sensible. The classical predecessors to contemporary physics, the science-based approach to understanding nature, began in the earnest with the work of Isaac Newton, and this is from the book Quantum and the Free Will by Henry Stapp, 2017, if I don't misnomer it. This is actually available as a PDF. I'm not supposed to mention that, but it's true. The science-based approach to understanding nature began in earnest with the work of Isaac Newton, who, it seems probable to me, that God in the beginning formed matter. Get the sun glaring in my eye here, see if I can fix it. That God in the beginning formed matter in solid, massy, hard, impenetrable, movable particles. But the core message of quantum mechanics is that this solid particle conception of matter is a figment of Newton's own imagination. A pure fiction, completely unlike the stuff that constitutes the constituents of the material world, as it is understood in the orthodox quantum mechanics. In that new theory, the mathematically described world in which we find ourselves embedded has the nature of a set of potentialities for the occurrence of certain kinds of perceptions. And these potentialities behave in many ways more like mental realities than like the solid particles that Newton described. Moreover, those Newtonian particles were presumed to interact with one another primarily by contact. Yet, according to Newton, they also attract each other by the force of gravity, which acts instantaneously over astronomical distances. When accused of mysticism because of this assumed instantaneous action at a distance, Newton replied that one body can act upon another at a distance through a vacuum without the mediation of anything else, is to me so great an absurdity that I believe no man who has in philosophical matters a competent faculty sorry, disturbances here. Sorry about that. Newton obviously rejected. I believe no man who has in philosophical matters a competent faculty of thinking can ever fall into it. Newton obviously rejected as nonsense the idea of an immaterial, instantaneous action at a distance. Yet, he offered no hypothesis about how the information concerning the location of a source of gravity could be instantaneously conveyed to a faraway system. He justified his mysterious assumption by the fact that it led to an understanding of many known astronomical and terrestrial empirical such as the orbits of the planets, the rising of the tides, and the falling of apples. Nothing goes faster than light. More than 2 centuries later, Albert Einstein proposed an explanation that made gravity's influence non-instantaneous, and indeed transmitted at the speed of light. Einstein's theory demanded, moreover, that no influence of any kind could transfer information faster than the speed of light. Very important. This condition became a bedrock principle of physics that was generally accepted by scientists. But the challenge of maintaining it in the face of 20th century empirical findings, or actually dealing adequately with its failure, has become the most basic task of science of our era. Our entire scientific worldview rests upon the completion of this task, which is entangled with our science-based understanding of our own human nature. And this is very important. We need to understand there are no other way of understanding the human nature today than the classical Newtonian way. Anything you add to that will be above, but the foundation will always be Newtonian, because there is no better explanation. I hope you get it. Saying that you believe in some other explanation will make you an intellectual, dishonest person. It does happen though, but I would say it's horrid dishonesty. Descartes' Dualism. These issues concerning the basic nature of things were brought into focus before Newton was born by the writings of the great French philosopher and mathematician René Descartes. He argued that what exists is divided into two different kinds of things. Things that occupy locations in three-dimensional space at instant of time, and entities that think. This Cartesian duality set the stage for the developments of science that followed. It allowed the conceived reality to be divided, actually, into three different kinds of things: material properties, mental realities, thinking entities. Material properties are features of things that are built out of particles and their associated energy-carrying fields. Mental realities include your thoughts, ideas, and feelings. A thinking entity is an entity that is experiencing mental realities. An example of a possible Cartesian material property is the location of a tiny Newtonian-type particle whose center is located at each instant of time at a point in 3D space. Very important. With the rest of it lying nearby, around that point. This is also a bit of a mystery to me, but the two examples of mental realities are your feeling of pain when you touch a hot stove, and your experience of the color red when looking at a ripe tomato. An example of a thinking entity is the you that is now experiencing the reading of this book. It thinks your thoughts, knows your ideas, and feels your feeling. It is the I of Descartes' famous I think, therefore I am. Descartes recognized that the mental events occurring in a person's stream of conscious experiences are associated with the material processes occurring in that person's brain. But he maintained that these mental realities are fundamentally different in kind from the corresponding material activities in the brain. This difference is the famous or infamous Cartesian distinction between mind and body, or mind and brain. Isaac Newton, building on Descartes' ideas, focused his attention on the material aspects. He formulated mathematical laws of motion. that account in a detailed way for the motions of the planets in the solar system, for the orbit of the moon around Earth, for rising tides, falling apophis, and for a host of other observed features of the material universe. This account makes no mention of any influence of mental realities upon material properties, and is called classical mechanics or classical physics. Do you remember that? By virtue of these laws applied universally to all material things, living or dead, a classical Newtonian type universe is deterministic. This means that the entire history of the universe is fixed for all time, and once the initial conditions and the mathematical laws of motion are specified, the aspects of the material universe that are not fixed the aspects of the material universe that are not fixed by the general laws and are thus limited to the selection of the initial conditions and the choice of the assumed time invariant laws of motion. Specifying these two inputs then determines every material event that will ever occur. No matter-based feature is left to chance or to the will of either man or nature. Well, of course, nor God, as we all know. This early science-based way of trying to understand reality in terms of matter alone, with no essential input from a mental realm, is called materialism, or sometimes physicalism. Philosophical torment. I like the title of this. Philosophers have been tormented for centuries by this seeming verdict of science that reduces human beings to mechanical automata. Our rational thoughts and moral sentiments were rendered incapable of deflecting in any way our bodily actions from the path ordained at the birth of the universe by the purely machine-like material aspects of nature. That conception of reality destroys the rational foundations of moral philosophy. How can you be responsible for your actions if they were completely determined before you were born, and indeed at the birth of the universe? The torment is not confined to moral philosophers. The great 19th century physicist John Tyndall touched upon it when he wrote, "We can trace the development of a nervous system and correlate it with the parallel phenomena of sensation and thought. We will see undoubting certainty that they go hand in hand, but we try to soar in a vacuum the moment we seek to comprehend the connection between them. The core difficulty here is that mental realities, which certainly do exist, have no rational place within the framework of 17th to 19th century science. They are logically disconnected appendages that are added on ad hoc, Sabine Hossenfeller, simply because we know that they exist. But their effects on what happens in the material world are, according to classical mechanics, the same as if they do not exist at all. The reason we seem to be soaring in vacuum, as Tyndall bemoans, comes from the materialistic viewpoint of classical mechanic. That way of thinking, in order to be complete, must permit the existence of thoughts we actually experience. Yet it provides absolutely no logical foundation or even tiny toehold for any rational understanding how human consciousness or feelings can arise from the logical foundation provided by the materialistic precepts of classical mechanics. The Copenhagen shift to a pragmatic stance. During the first quarter of the 20th century, a series of experiments were performed that proved the properties of matter at the level of its atomic constituents. The results were incompatible not merely with the fine details of classical mechanics, but with its basic tenets as well. Responding to this catastrophic breakdown of classical mechanics, scientists created, during the first half of the 20th century, a new theory called quantum mechanics. It is based on concepts profoundly different from those of classical physics, yet yields extremely accurate predictions about the outcomes of all reliable, replicable experiments, both old and new. It also leads to a revised understanding of our own human nature that is radically different from the effectively mindless mechanical conception entailed by the materialistic principles of classical mechanics. The original version of quantum mechanics is called the Copenhagen Interpretation because it was hammered out in intense discussion centered at Niels Bohr's Institute in that city. In order to dodge various philosophical difficulties, quantum theory was originally offered not as a theory of reality, but rather as a pragmatic set of rules. These rules were designed to allow physicists to make reliable statistical predictions about what observers will experience in response to their various contemplated alternative possible probing actions of observation or measurement. Virtues of realism. But the new theory can also be interpreted realistically or ontologically as one understanding of reality itself. A realistic interpretation is, in fact, needed if one seeks to extract from science any deep insights into the nature of the universe and our human selves within it. The thesis expounded in this book is that von Neumann's, nota bene, I might misled you before, but it's von Neumann's orthodox formulation of quantum mechanics, elucidated where needed by the ideas of Heisenberg, Dirac, Wheeler, and the mathematician, logician, and philosopher Alfred North Whitehead, and updated to the relativistic form developed by Tomonaga and Schwinger, can be regarded as a theory of reality that is sufficiently detailed and accurate to deal with the issues of the general nature of our mental aspects and of the causal connections of our conscious minds to the material world in which our brains and bodies are embedded. A condition on the scope of a science-based theory of reality. An adequate scientific theory of reality ought to accommodate all the regularities of human experience. This includes not only the results of experiments pertaining to astronomical, terrestrial, and atomic physics, but also to the experiences of normal everyday life. These ubiquitous subjective data reveal a strong positive correlation between a person's felt mental intention to perform a simply bodily action, such as raising an arm or a finger, and a subsequent perception of the intended bodily action. Empirical data of this kind constitute the rational foundation of our active, meaningful lives, and for they effectively instruct us how, by making appropriate mental efforts, to influence our bodily actions in mentally intended ways. A theory of reality that fails to provide a rationally coherent account not only on astronomical, terrestrial, and atomic data, but also this directly experienced mind-body relationship is fundamentally deficient. Such deficient theory include materialistic classical mechanics, which claims that everything real is created by the interaction of matter with itself. It claims that all those things are created by matter in interaction with itself. You should taste how that feels to listen to. But then fails to explain how these purely material processes generate our conscious perceptions and our causally efficacious mental efforts. Similarly inadequate is any non-standard materialistic version of quantum theory that does not account for our subjective experiences and the capacity of mental effort to influence in desired ways the behaviors of our bodies. The standard orthodox quantum mechanics can, by virtue of its mathematical structure and the words used to describe it, be naturally interpreted realistically, and when thus interpreted, it brings our mental aspects into the dynamics as elemental realities that are causally linked to matter via specified laws of nature. I call this interpretation realistically interpreted orthodox quantum mechanics. It evades the logically impossible task of explaining how felt mental properties can be constructed out of mechanical material properties alone, by postulating the elemental existence of both mind and matter, and then describing in rational mathematical terms how they interact with each other. Just going to fill up some more coffee here. Give me a second. Von Neumann's orthodox formulation of quantum mechanics. The standard quantum theory against which all others are compared is von Neumann's orthodox formulation of Copenhagen quantum mechanics, or more specifically, the updated version called relativistic quantum field theory, abbreviated as RQFT. It is this relativistic orthodox version of quantum theory that is propounded in this book. As will be presently explained, this theory is about both 1. the dynamical interaction of matter with itself. And that accounts for the unobserved behavior of material substances, and 2, the interaction between mind and matter that constitutes the highly non-trivial process of observation. In quantum mechanics, the mind-matter interaction is mathematically very different from the matter-matter interaction. And it's different in a mathematical way that entails that the observer it entails that the former can never be reduced to the latter. The difference in these two dynamical processes is directly connected to Heisenberg's seminal 1925 discovery, which quickly led to the creation of quantum mechanics. This new theory gives detailed explanations of the plethora of 20th century data of atomic physics that had resisted all attempted explanations via the materialist precepts of classical physics. Heisenberg's discovery was that the process of observation, whereby an observer comes to consciously know the numerical value of a material property of an observed system, cannot be understood within the framework of materialist classical mechanics. A non-classical process is needed. This process does not construct mind out of matter or reduce mind to matter. Indeed, it explains in mathematical terms how a person's immaterial conscious mind interacts with that person's material brain. An immaterial mind lies beyond the ken of a materialistic approach, and the mathematics that describe the process of conscious observation is not reducible to the mathematics that describes the process of the unobserved evolution of matter. The eminent Hungarian-American mathematician and logician John von Neumann cast the ideas of Copenhagen quantum mechanics into a rationally coherent and mathematically rigorous form that is widely used by mathematical physicists and also by others who require mathematical and logical precision. Nobel laureate Eugene Wigner labeled von Neumann's formulation orthodox quantum mechanics. Remember that one, it's going to be important. The label orthodox is appropriate in the sense that many, and perhaps all, mathematical physicists take it to be the logically and mathematically precise formulation of the Copenhagen ideas. Von Neumann approached these mind-related issues by considering what amounts to a tower of good measuring devices, where each device associates one-to-one each input to a corresponding output. And the output of each device is the input to the device above it. On the top of this tower lies an observer's conscious ego that can both receive perceptual inputs and instigate probing actions by means of its interaction with associated brain. About the entry of consciousness into dynamics, von Neumann says, first, it is the inherently entirely correct measurement or the related process of subjective perception is a new entity relative to the physical environment and is not reducible to the latter. Indeed, subjective perception leads us into the intellectual life of the individual, which is extra-observational by its very nature. This first quote emphasizes that within von Neumann's orthodox representation of quantum mechanics, the process of subjective perception is not reducible to the process that governs the interaction of matter with itself. Our subjective conscious perceptions are, as Descartes had declared, neither equivalent to nor reducible to the behavior of matter. I take this irreducibility of mind to the behavior of matter to be, on the basis of this quote and everything else said in von Neumann's book, a core feature of realistically interpreted orthodox quantum mechanics. The second quote is, it must be possible to describe the extra physical processes of subjective perception as if it were in reality in the physical world, i.e., by assigning to its parts equivalent real parts in the objective world in ordinary space. I take these equivalent parts to be primarily the neural or brain correlates of our conscious perceptions. The third quote is, now quantum mechanics describes the events which occur in the observed portion of the world, so long as they do not interact with the observing portion, with the aid of process 2, but as soon as such an interaction occurs, i.e. a measurement, it requires the application of process 1. This third quote introduces two very different processes, process 1 and process 2. Process 2 is the quantum analog of the dynamical process of classical physics. Like its classical counterpart, process 2 involves only the material aspects of nature and is deterministic. It is also unitary, which means essentially that its action merely shuffles information around without losing any of it. This process too depends in no way on the mental aspects of nature, but the material physical state of the universe upon which process 2 acts contains the neural correlates of our perceptions that were introduced in the second quote. Process 1 is the process that generates perceptions. Each process 1 action is associated with a particular conscious observer. It has a mathematical form that is very different from that of process 2. Process 1 is not unitary, but is instead projective. It is associated with the subjective occurrence of a perception coupled to the instantaneous elimination from the material universe of all aspects that are incompatible with the occurrence of that perception. Thus, this process has 2 phases. The first phase selects a possible next subjective perception on the part of the observer. This possible potential next perception defines a corresponding brain correlate, which has, according to the theory, a certain statistical weight. The second phase of process 1 then reduces the material universe to 2 parts. One that definitely contains this brain correlate, and the other that definitely does not contain this brain correlate. And it actualizes either one part or the other. This choice is made by nature between the 2 parts, accords with a certain statistical rule known as the Born rule. This Born rule choice is the unique place where an element of chance enters into the quantum dynamics. Here we have it. The preceding choice of a possible next perception reflects the history and the felt values of the observer and is identified with what that observer feels is his or her personal subjective choice of what physical property of the observed system to probe or inquire about. No element of chance is ascribed to this choice made by an observer of a particular possible probing action. The 2 phases of process 1 are manifestations of the differing points of view of Heisenberg and Dirac, cited by Bohr, in which Heisenberg emphasized the free choice on the part of the experimenter of which probing experiment to perform, while Dirac emphasized the choice of the part of nature regarding which outcome occurs. The whole process resembles, as emphasized by Wheeler, the game of 20 questions, in which a succession of yes/no questions is posed, which each eliciting a yes or a no response. Von Neumann cast into rigorous mathematical form the key ideas of the founders, insofar as they strayed from the official pragmatic path and tried, as scientists rightfully do, to understand what is really going on. The fact that the generation of conscious perception involves a dynamical process that is structurally and mathematical extremely different from the deterministic matter-driven process that governs the unobserved evolution of reality is the basic difference between materialistic classical mechanics and its quantum successor. Let me try to put this in a parenthesis. The main difference, the foundational difference, is that classical mechanics deals with unobserved events. And this is to be paralleled with mathematics in a Platonic way, where the mathematical entities are not observed or thought of, and they still are assumed to exist. Not potentially, very careful, don't misjudge that as potentially. This is much different. And of course, the Gödel theorem, there unobserved axioms could be responsible for sort of regulating all of mathematics. Quantum mechanics only deals with observed things. Classical physics deals with unobserved things. It's its main object, and thereby covering some of the observed events. Not all though. The classical theory presumes that all aspects of nature can be explained purely in terms of the action of matter upon matter, but the quantum world differs in a fundamental way from that core precept of materialism. This huge structural difference in the real, i.e. quantum, world between the matter-matter interaction and the matter-mind interaction makes manifest the extreme naivety of trying to comprehend the connection between mind and matter within a materialistic framework already established by Newton, Descartes et al. In the quantum world, the observing processes of acquiring empirical knowledge must disturb, or perhaps even bring into existence, the values we observe. By virtue of Heisenberg's discovery, the process of our acquiring knowledge about the material aspects of nature cannot merely reveal already existing values. The process of acquiring knowledge injects our mental aspects in an essential way into the process that determines what we will find if we look. This non-materialistic action injects the mind of the observer as a causal agent into realistically interpreted orthodox quantum mechanics. It gives our mind an essential dynamical role to play, and hence a natural and rational reason for them to exist. It is quite interesting. So Henry Stapp, without a doubt, is sticking to the orthodox observable quantum mechanics, and it's implied the other ones, for good reasons, have strayed, but for practical reasons. And it is not unjust to say that Henry Stapp is taking up the dagger, the banner, and lead the way that von Neumann first stepped on, and thereby making predictions stronger, and also at the very same time building a realistic worldview. I say thank you very much and have a very pleasant afternoon. Bye bye for now.